Hello students, we're going to start looking at Unit 3.4, which is solving equations with variables on both sides. So up to this point you've been doing multi-step equations and the variable has been on just one side of the equation, and you've used inverse properties to isolate the variable term and ultimately isolate the variable and solve for the variable. Now they're going to just add another little layer of complexity, and we're going to have variables on both sides. So let's take a look with starting on 3.4 on example 1. Example 1 says to solve this equation, 7x plus 19 equals negative 2x plus 55. All right, the rule of thumb is this. You see you have a variable term here and a variable term here. What we usually do is we pick on the variable term that has the smallest coefficient. So in this case, negative 2 is smaller than 7, so we're going to use that. We're going to move that one first. The reason that we do that is that we want to end up with a positive coefficient. The reason we want to do that is just that it reduces numbers of errors. Now, it wouldn't be wrong for us to pick on 7x first and move that over to the other side. It's just that conventionally it's usually better to pick on what we call pick on the little guy. And so I like to tell my students this is the one time bullying is okay. You can always pick on the little guy here when you got variables on both sides. All right, so we're going to start with moving the 2x, the minus 2x. And so we're going to still use inverse operations to do that. So I'm going to add 2x to both sides. All right, now when I do this, I get 7x plus 2x. That's going to give me 9x plus 19 equals 55. And moving the 2x over here gives me a positive coefficient here. So it just makes it one less step having to deal with negatives on the coefficient. All right, so next step then now is we want to isolate our variable term, which we now have on the left side. And so we're going to subtract 19 from both sides. And when I do that, I get 9x equals 36. All right, and then the rest is, pretty much the way that you've been doing it all along. So you know now that you need to divide each side by 9, and you're going to get x equals 4. And of course, you can always go back to your original equation and check your solution. And by placing the 4 inside for x and checking to see that the left side equals the right side. So does that equal negative 2 times 4 plus 55? And we get 28 plus 19 equals negative 8. And we're still questioning. We don't know yet. That's 55. And then when we actually do the arithmetic on here, we discover that 47 equals 47 and that our solution of x equals 4 checks out. All right, so now let's move on to example 2. And in this case, what we're going to do, we still are picking on the little guy here, but I guess the point that I want to make here is that sometimes, you can see that the variable is already isolated on this side. So even if this were a plus and this was larger, you might still want to pick on this term anyway. As it turns out, it is the little guy here because it's negative 9, that's positive 6, and that works out. But if for some reason that was even larger than the other side, you might want to still pick on that and move it, because then it's just one move of moving a variable over, because otherwise if you move the 6y in the other direction, then you'd still have to move the 80, and that's 2 steps. So some of this has to do with efficiency and what makes sense. But let's go ahead. We're gonna isolate the y, the 9y. We're isolating y, and so I'm gonna move. We're gonna add 9y to both sides, and so I end up with 80 equals 15y, and again I'm gonna divide both sides by 15. And I get, what is it? What is that? Oh, okay, so this is not going to go into it nicely. It looks like I'm going to have to divide each side by 5. And so 5 goes into 80 16 times, and 5 goes into 15 3 times. So I end up with a fraction here for this. And again, I could go back in here and check it out and put it in, place it in both of the y's and check that the left side equals the right side. All right, so now what I'd like you to do is we're going to work through the checkpoint, but at this stage of the game, I'd like you to pause the video and work through 1, 2, and 3 of the checkpoint, and then come back and press play. Okay, I'm going to work the checkpoint out, and I'm assuming that you have already paused and are now coming back, and we're going to do the checkpoint. So number 1 says 34 minus 3x equals 4x. All right. So in this case, I want to move the negative 3x over to the other side. I'm going to get rid of the 3x by adding the opposite of negative 3x from this left side, and I get 34 equals 7x. And, oops, is that right? Oh, it's 14x. Okay, that explains it. Okay, let me try that again. I was like, that's not looking like what I should have. Okay, so let me try that again. 34 minus 3x equals 14x. Okay, picking on the little guy, and also we're just being efficient and moving the variables over, which are already on the right side anyway, be the easiest. And we get 34 equals 17x, and now I'm going to divide each side by 17, and we end up with 2 equals x, or in other words, x equaling 2. All right, so that's number 1 of the checkpoint. Number 2 is 5y minus 2 equals y plus 10. All right, so now we're going to pick on the little guy. So I've got 5y here. This has got a little invisible 1 in front of it, and we just don't see it. It's a 1y. And so which one is the little guy in this case? Well, it is y, of course. So we're going to pick on that first. And so since this is a positive y, we're going to subtract y from both sides. And then when we do that, 5y minus 1y is going to give me 4y minus 2 equals 10. And now I'm going to add 2 to both sides. And I get 4y equals 12, and I'm going to divide by 4, and then divide by 4, and I get y equals 3. Okay, and then the last one I'm going to do is 3, which is minus 6x plus 4 equals negative 8x. All right, now, this is one of those ones where, technically speaking, negative 8 is a smaller number than negative 6. So if I were following the, pick on the little guy rule, I might want to pick this and move this. But since I already have the x on a right side, and it's just a matter of moving this over, in this case, I'm actually going to pick on the big guy, and because it'll save me a step. Because if I move the 8x over here, then I'm going to have to move the 4 back over there, and that's 2 steps. Now I can just move move the 6x over to the other side, and then that's one less step I have to do. So now I get 4 equals negative 2x. So you can see in this case, since I didn't pick on the little guy, I ended up with a negative coefficient. It's no big deal, but sometimes it's nicer to deal with a positive coefficient, but it's really not a big deal. And now we end up with negative 2 equals x, or in other words, x is equal to negative 2. All right, I hope that that's clear. All right, so let's continue on with the lesson. We're going to look now at example 3, and they're going to try to add another layer of complexity on here and give you some more stuff to do before you can really start solving for the variable. So in example 3, we see that 3x minus 10 plus 4x equals 5x minus 7. All right, now, so the bottom line is before you start this going back and forth across the equal sign of the equation, you want to make sure that each of the sides is 100% simplified before you do that. Now, what does that mean? That means that there's only one kind of each term on each side before you start making decisions about moving things from side to side. So when I look at this and I look at the left side, I can see that I have a 3x and a 4x here. Those are like terms, and what I want to do first is combine those before I start moving them around. So I'm going to add the 3x. So this is a positive 3x, and of course I've got a plus sign in front of this, so that means I'm going to combine two positives, and I'm going to get 7x minus 10, I'm bringing down the 10, haven't done anything with that, equals 5x minus 7. Now I'm ready to make decisions about which side the variable is ultimately going to end up on. And in this case, since I've got equal numbers of terms on both sides, it makes sense for me to go ahead and pick on the little guy here, in which this case it's 5x. So I am going to subtract 5x from each side. All right, and then when I do that, I get 2x minus 10 equals, and remember there's a minus sign in front of here, so I got to bring down minus 7. All right, and now I'm going to add 10 to both sides. Okay, and now I get 2x equals 3, and now I have to solve for x. I'm going to divide each side by 2, and I end up with x equals 3 halves. And again, I could check this again by going back and putting it back into the equations and making sure the left side equals the right side. All right, now, so we're going to do the checkpoint again, checkpoint 4 and 5 at the bottom of page 152. So go ahead and pause the video now, and you do 4 and 5, and then come back, and we will see what we got. Oops, I don't know what happened there. Okay, here we go. All right, so, okay, if you're coming back, I'm assuming you finished 4 and 5 at the checkpoint, and now we're going to work through those together. We got 5x minus 3x plus 4 equals 3x plus 8. All right, well, let's look at the left side. Is this perfectly simplified? Is the left side simplified? No, it is not, because I have two x terms that I can combine. So 5x minus 3x is 2x, and then that's plus 4 equals 3x plus 8. Okay, now I can pick on the little guy, which in this case it's the 2x, so I'm going to subtract 2x from both sides. Okay, that cancels out. I get 4 equals 3x minus 2x is 1x, or just x, plus 8. And now I'm going to subtract 8 from both sides, and I end up with negative 4 equals x, or in other words, x equals negative 4. All right, now let's do number 5. 6x plus 3 equals 8 plus 7x plus 2x. All right, so we got 6x plus 3 equals, and of course we've got to simplify this side, so we got 8 plus 9x. All right, now we're going to pick on the little guy, which is the 6x now. I'm going to subtract 6x from both sides. And that cancels out. I get 3 equals 8 plus 3x. All right, now I'm going to subtract 8 from both sides. I get a negative 5 equals 3x, and now I'm going to divide both sides by 3. And I get negative 5 thirds equals x, or in other words, x equals negative 5 thirds. All right, I hope that's clear. All right, so now you've learned all the various ways that you can solve an equation. So you've learned to pick on the variable that's the smallest variable, or if there's only one variable on one side, then move the other variable to that side, and to simplify both sides of the equation first before you go on to solve. Now, the next part of this section has to do with the fact, it's more conceptual, it has to do with the fact that, this whole chapter is called linear equations. So, when we're talking about linear equations, what are we talking about? Well, we're talking about equations that, and you're going to learn about this in chapter 4, that if I were to graph these equations, they're going to graph into lines, okay? They make lines. So when I'm setting two sets of variables equal to each other, what I'm really doing is I'm I'm setting two lines equal to each other. And when I'm solving for the variable, what I'm really finding is I'm finding where the x value where they intersect. So we like to say that there's like three things that can happen with two lines, okay? Two lines could intersect, and if they do, then x will have a solution. You'll be able to solve for x. Okay, and you'll find out what x is. And the x that you find is going to work in both equations, both sides of, in other words, both sides of the equation that you're looking at. One side's a line, the other side's a line. The other thing that could possibly happen with two lines is they end up being parallel. And if they're parallel, what's going to happen is they don't intersect at all. And you're going to end up with a situation where you get kind of nonsense. You'll get a nonsense answer when you follow your algebra through. And so we call that no solution, because if their lines are parallel, that means that they're never going to intersect. So you're not going to find a solution. The third thing that could happen with two lines is that the lines could be defining the same exact set of points. So I have one line lying here, and then I come through and I have another line just lying right on top of it, okay? In other words, you got two lines defining the same exact set of points, and under those circumstances, if that happens, that means you have infinite solutions, okay? And in fact, it means that you have what they call an identity. An identity means that one side of the equation is exactly the same thing as the other side of the equation,